Okay, this lesson is going to be on the formation of something called an ion. And an ion is basically an atom with a charge. All atoms are neutral particles. So if you look at like oxygen on the periodic table, you'll have an O in the middle, an atomic number of 8, and a mass number of 16. And as we studied before, this means that oxygen has 8 protons and 8 electrons. And if you have 8 protons, that equates out to a charge of plus 8, because each proton is plus 1. And if you have 8 electrons, that equals out to a charge of minus 8, because each electron has a charge of minus 1, which gives you an overall charge of 0. And what we're going to do is, when we talk about making chemical reactions, we ultimately are exchanging electrons. So we're going to change this. The number of protons are never going to change, though. So by changing the number of electrons, we're going to change the outcome of this right here. We're not going to have an overall charge of 0 anymore. So for example, oxygen, when it forms an ion, is going to keep its 8 protons. However, it's going to add 2 electrons to give an overall minus 10. And when you combine that with the plus 8 from the protons, you get an ion with a negative 2 charge, and we write that like this. Now, how we go about figuring that out is using the periodic table and understanding the structure of an atom, which is what we're going to talk about now. So let's take some time to look at the basic structure of an atom. So for our example, we're going to start with the element magnesium. If you look on the periodic table, you'll see magnesium in the second column. It has atomic number of 12, mass number of about 24, which again equates out to 12 protons and 12 electrons. And now we have to look for how the structure is. It also has 12 neutrons for magnesium, but for our purposes, the magnesium really are not going to play a very large role. For an atom, all of the positive charge is found inside the nucleus, which is the center region here. So we'll make our protons be red here. So all 12 protons are found inside the nucleus with the neutrons, and then going around the outside, of the nucleus are our electrons. Now we're showing them in rings. In reality, it doesn't really have that structure, but this is called the Bohr model of an atom, and it's the easiest one to show basic overall layout. We call these orbitals, or we call them electron clouds, but we'll take a look and see where the electrons go. So I know I have 12 electrons. The first energy level, which is the first ring that you'll see right here, can hold 2 electrons. So this ring can hold 2 electrons. So I put 1, 2 there. Since it's the smallest area, it can hold the fewest electrons. All other rings or energy levels can hold 8 electrons in them. So I started with 12 electrons. I took away 2 and put them in the first ring, which still leaves me with 10. So that means I can put 8 out here and fill the second level. So 1, 2, 3, 4, 5, 6, 7, and 8. Now, the second ring's full, so I take away 8. It still leaves me with 2, which means we need to go out to the third energy level for magnesium and put our last 2 electrons there. The problem with this outside energy level here is that it's not full. It does not have 8 valence electrons in it. And valence electrons are the electrons that are the farthest away from the nucleus. So for magnesium, it's the third energy level. So this third energy level only has 2. So when magnesium forms an ion, its job is to lose or gain, or any atom's job is to lose or gain electrons in order to fill this outside energy level. So for magnesium, it either has a choice of adding 6 more electrons here and filling the outside, or donating these 2, erasing the outside ring, and then having a full outer second energy level as its valence electrons. Then what we find out is that all metals, which are going to be in groups 1, 2, and 3, will donate their electrons. So for magnesium, it's going to donate its electrons just, just like this. They're going to go away. So for magnesium, this outside ring disappears, and you're left with a second full energy level with 8. However, now magnesium still has 12 protons, but only 10 electrons. So you have a plus 12, a minus 10, which leaves you with a plus 2 charge. So magnesium was an example of a metal, and all metals will donate electrons. We could also look at an example of a nonmetal. For our purposes, we'll use sulfur, which has atomic number 16 and a mass number of 32, which again, this is going to equate out to 16 protons and 16 electrons. Now, if we want to draw out this atom in our Bohr model, we will put all of the positive charge inside the nucleus, and then we are going to put our first energy level, and we said that we could put 2 electrons there. So if I put 2 there, that leaves me with 14 more, so I need to draw a second energy level. And in the second energy level, we can put 8, so we have 1, 2, 3, 4, 5, 6, 7, 8 electrons there. So I had 2 in the first, 8 in the second, so I've used 10, which still leaves me 6 more, so just like magnesium, I need that third energy level. And we'll have 1, 2, 3, 4, 5, 6 electrons on the outside, which again is not full. If you remember, our valence electrons are electrons that are farthest away from the nucleus. We want to have that full, that outer energy level. It's what atoms want, it's what elements want, and right now it is not the case for sulfur. So it does have an overall charge right now of 16 positive, 16 minus, which is overall a 0. But sulfur does not want to remain this way. Just like magnesium donated its outside electrons to lower down to the second energy level, sulfur has a choice to make too. And in this case, it's a better choice to add 2 more as opposed to losing 6. So it's always a numbers game. So for this element, we are going to, when it forms an ion, we are going to add 2 electrons, which means now I have plus 16 from the protons minus 18 from the electrons, which gives a negative 2 ion. So we write that as sulfur minus 2. Now this is the whys behind ion formation and why the elements do what they do in order to form other compounds and become more stable. But there is a method to use the periodic table as well. That's what we'll do right now. So one other thing worth mentioning here is that all metals on the periodic table, metals will donate electrons, and all nonmetals will accept electrons. And because of this, when you donate electrons, you lose negative charges, so you become positive ions. And when you accept electrons, you become more negative, and you form negative ions. Now we're going to take a look at our periodic. So the other way to figure out what ions will form and valence electron numbers and everything else we've shown so far is to know how to read your periodic table. So your periodic table is divided into groups, or families, which are the vertical parts of the periodic table, and periods or rows, which go across the periodic table this way. For what we're doing, we're going to focus in on the families, the groups of elements. So we have group 1, the alkali metals, group 2, the alkaline earth metals, group 3, group 4, group 5, group 6, group 7, the halogens, and group 8, the noble gases. Now your periodic table also gives this away. If you look up here, you'll see 8A, 7A, 6A, 5A, 4A, 3A, 2A, and 1A. And if you just remove the A, so the A means it's the main block element, it gives you 1, 2, 3, 4, 5, 6, 7, and 8 we're going to ignore the transition metals for our purposes. We are not quite there at this time. So we're going to write this in there so I know that this is group 1, this is group 2, 3, 4, 5, 6, 7, oops, 7, and 8. Now, the nice part about knowing your group numbers is that your group numbers tell you how many valence electrons elements have in that family. Every element in the same family has the same amount of valence electrons. So everything in group 1 has 1 valence electron. Everything in group 2 has 2 valence electrons. Group 3 has 3 valence electrons. Group 4 has 4. Group 5 has 5 valence electrons. Group 6 has 6 valence electrons. Group 7 has 7 valence electrons. And Group 8, the noble gases, already have 8 valence electrons. Every single element on this periodic table, with the exception of 2, want to have 8 valence electrons. Hydrogen does not want to have any electrons, and helium wants to have only 2 because it's in the first energy level. Everything else wants to act like a noble gas. Noble gases already have 8, so they don't give away electrons and they don't accept electrons. They are non-reactive, which is why we use things like helium to fill balloons with, because we know that no matter what happens to it, it's not going to react with oxygen and explode. It is a non-reactive gas. It has a full outer shell of electrons, therefore fulfilling its octet rule. Octet rule is the rule of 8. It says that electrons want to have a full outer shell, which in the case of almost every electron means it has 8 electrons. Now, the other thing that we can use from this is if I know how many valence electrons something has, I can figure out if it's going to accept or donate. So for the first group, it's only got 1, so it's much easier to lose that 1 valence electron it has and drop down an energy level. So this is going to subtract an electron, which gives them a +1 charge. The second group over here has 2 valence electrons, and it's still easier to lose 2 and form a +2 ion. The third group has 3 valence electrons, and it's easier to lose 3 than to gain 5, so it will form a +3 ion. So you'll have something like aluminum +3, or magnesium +2, or sodium +1. The fourth group we're going to ignore because they do not form ions, carbon, silicon, and such. Group 5, though, has 5 valence electrons, and it is an acceptor. It's a nonmetal, so it's easier in this case to add electrons. So here we're going to add 3 electrons, and therefore form -3 ions. Group 6, it's easier to add 2 than to donate 6. So you're going to add 2 and form -2 electrons, or ions. Group 7 only needs 1 more to fulfill its octet rule, so it for sure is going to accept that. And when you add 1, you form -1 ions. Again, group 8 already has 8 valence electrons, so it does not accept or donate. They are stable. I hope you found this lesson helpful. Hopefully you better understand valence electrons and ions. And remember that the most important thing to remember is that when you donate electrons, you form positive ions because you're losing negative charge. And when you accept electrons, like nonmetals do, you form negative ions because you are adding negative charges. Good luck on your test tomorrow. If you have any questions, come see me before school.